Hello friends, I have come here with another question that I found while browsing on the YouTube. This question is also quite interesting. So here what we have to do, we have to find out which shape has a greater perimeter. So as we can see, there is a square and there is a circle and they are arranged in a way as shown in the figure. We can label this square as A, B, C, D. Friends, it's obvious that the center of the circle will not coincide with the center of the square because it is not a perfectly inscribed circle as we can see here. So what we are going to do, we'll mark the center as O. We are going to mark the center of the circle as O. Suppose, let me take blue color. This is O. This is center of the circle O, and we'll join OB and OC. Okay, here we have just in line with O, we have this point E, and we can extend this line further and let us take this point as F. Okay, we know that perimeter of a square is what, 4 into side. We assume side of the square as 2a. Let us assume side as 2a. So if this is 2a, this BC will become 2a. So we have BF here A and FC also A. Okay. Then we are going to join this point B with point E and also point C with point E. So okay. So if we have assumed that the side of the square as 2a, now we'll let the radius of circle be R, VR, and circumference will be 2 pi r. Okay, so if the side of the square is 2a, then CD will be 2a and that will be equal to EF. So EF also becomes 2a. So we can calculate this angle. Let us say theta. As we can say, what we I'm trying to establish is that BC is a chord. The angle subtended by BC at the center, suppose this is 2 theta, then this will be what, half of this theta. This is what I'm going to apply here. Angle subtended at center is double the angle at circumference. This is a theorem of circle. So see here, if this is 2 theta, then it will get bisected. This will be theta and this will also be theta. Similarly, this will be theta by 2, this will be theta by 2. Okay, so we can calculate from here tan theta by 2 in triangle EFB. Tan theta by 2 will be equal to perpendicular upon base, that is BF upon EF. So here we have BF is as A and EF as 2A, so it is 1 by 2. Okay, when tan theta by 2 is 1 by 2, we can easily calculate the value of tan theta, because we know that tan theta is equals to 2 tan theta by 2 upon 1 minus tan square theta by 2. Here we have 2 tan theta by 2. 2 tan theta by 2 means 2 into 1 by 2 upon 1 minus tan square theta by 2, that means 1 over 2 and its whole square. 2 will get cancelled out, and here we are left with 1 minus 1 over 4, that will be 1 upon 3 over 4, that is 4 upon 3. So tan theta is 4 upon 3. 4 is what? Perpendicular, and 3 will be base. So if we apply this thing in triangle BOF, tan theta is equals to 4 by 3. That means BF over OF will be 4 by 3. We can take this as BF as 4 and this OF as 3. If this is 4, then FC will also be 4. So we can get the side of the square from here. What will be the side of the square? Side of the square will be 4 plus 4, that is 8. So we have got the side of square. Now again we'll see in this triangle only, if this is this OF is 3 and BF is 4, then obviously OB will be 5 by applying Pythagoras theorem, and 5 is also the radius. So we got the radius and we got the side of the square. So from here we can calculate the perimeter of square. Perimeter of square will be what? 4 into side. 4 into side is what? 8. That will be 32. And radius of circle is 5. So circumference will be 2 pi r. That means 2 into pi we can substitute as 3.14, and for r we have 5. So it is 10 into 3.14 and it is 31.4. So we can see here that perimeter of square is greater than perimeter of circle. So we got our answer that perimeter of square will be greater. This question I found on the YouTube, and it the person who has solved this question has used a different method, but I tried to simplify it, and in this way we can also obtain the solution for this question. Thank you.